So the problem at hand is to find the higher derivatives of the functions e raised power t sine t, tan of x, and then x sine of x. So let's see how we solve this. So question 2. So the first one is to find the second derivative, the third derivative of the function y equals to e raised power t sine of t. Now the first, we use product tool. Let this one to be u, this one to be v. So u prime v plus v prime u. So first derivative will be given by u prime is e raised power t times v sine t plus v prime is cos t. This will be e raised power t cos of t, which you can write as e raised power t into cos of t plus sine of t. Now from first derivative, we get second derivative, and still we use product tool. So let this one to be u, and all this bracket to be v. So u prime is e raised power t times v cos of t plus sine of t, and then plus u times v prime e raised power t. If we're getting this, we get negative sine t. This part will get positive cos t. Now opening brackets will have e raised power t cos t plus e raised power t sine t minus e raised power t sine t plus e raised power t cos t. Now you see this term and this term cancels out. So which means second derivative will be twice e raised power t cosine of t. And then lastly, the third derivative, we still use product rule. So let this to be u, this to be v. So u prime will be 2 e raised power t times cosine of t, that's v, minus v prime is minus sine t, so it will be 2 e raised power t sine of t. So you can write this as the third derivative is given by 2 e raised power t into brackets cos of t minus sine of t. Second part, we want second derivative and third derivative when function is tan of x. So solution. So given y equals to tan x, then we know that y prime is given by sec squared x. Then second derivative, we'll use chain rule. So by saying let u, remember this can be written as sec x raised power 2. So be sec x. So then u is like, now we have, if we call the first derivative as say f, then f will be the same as u squared. So second derivative will be the same as df du times du dx. So it will be 2 times u, differentiating this, a derivative of u when u is sec x is sec of x times tan of x. So which is the same as 2 u is sec x times sec of x tan of x. Sec times sec is sec squared. So this means second derivative of the function is 2 sec squared x times tan of x. Now, the third derivative will be given by, so we can let this one to be u, let this one to be v. So u prime v plus v prime u. So u prime, we have known that the answer is 2 sec squared x tan x. Then you multiply this one by v, which is tan x. And then plus v prime, this will be sec squared, and this will have 2 sec squared x. You multiply it by sec squared x. So which means this will give us 2 sec squared x times tan squared x plus 2 sec power 4 x. So this is what the function reduces to. And then lastly, 3, f double prime when f is x sine of x. Now the first derivative, so let this one to be u, this one to be v. So u prime v plus v prime u. V prime is 1 times v, you get sine x. V prime is cos of x times this will give us x cos of x. So this is the first derivative. And the second derivative, so differentiating this part, we get cos of x plus this, we use product rule. So let this to be u, this to be v. U prime is 1, so cos x. V prime is minus sin x times x will be x sin x. So when you work out this, you'll get cos of x plus cos of x minus x sine of x. So which is the same as 2 cos of x minus x sine of x. So this is the second derivative of the function f of x. Thank you.